Oh, okay, there we go. Sorry.
False start. Okay, we're starting the next ORTC community group meeting, preceding the IETF in Toronto. So there's a bunch of people in Toronto inside of a room together, as opposed to everybody in the Hangout this time, which is great.
And if you're in Toronto, we're in the business center in the Fairmont York Hotel, so come on over. There's probably room for 2 people, 3 people more.
It's in the lobby.
In the lobby.
All right. Hopefully, you won't have to stage a bouncer at the door. Okay, so this is our 5th community group meeting, and we've got. I don't even know if this list is accurate. I think we missed this slide, but we've got a bunch of stuff to discuss. I'm not going to read these here because I'm not quite sure that they're completely accurate. But we do have ICE restart, CNAME to discuss, some GRIP parameter issues, and stuff like that. So we'll go over it all a little bit later. If you go to the slide, so we're on slide 4, by the way. I don't see a slide change. Sorry, slide 2, sorry, 3. Yeah, there we go. A little confusion there. Okay, about this meeting, we got the link there. We do need a scribe, though, if someone is available to go on the ORTC, the IRC channel, not the ORTC channel, but the ORTC channel in IRC to scribe, as we discussed. That would be great. Do we have a volunteer? Because I can't exactly do that from while I'm reading. I don't hear anybody in the room.
An IRC scribe.
Is there anybody?
Okay.
Emil?
Emil says yes.
Okay.
Yeah.
Do you have the IRC link, Eric, handy, by the way?
I'll check out. I think so.
Yeah, it's irc.w3.org. Channel name is ORTC.
Okay, perfect.
I'm the only one in the room.
That's fine. Talk amongst yourself. All right, so next slide, ORTC Community Basics. Yes. So again, we've got the official W3C community group website you can go to. You can always go to WTC.org, which is the portal, which gets you everywhere that you need. Just a reminder, the public mailing list is for anybody, but we can only accept contributions from actual community group members because of IPR issues that everybody has to agree to. So keep that in mind if you would like to contribute, but you're certainly welcome to post. Next slide. Just a reminder, ORTC.org is the portal, and we track of all the outstanding issues on GitHub, and we just resolved a whole bunch. So by all means, go there and see the state of affairs. Slide 7, I'm actually going to ask Bernard to speak on this behalf because he's been diligently updating the draft with all of the outstanding issues and keeping track of them. So Bernard?
So I'll go over the general categories of issues that we've been dealing with. We'll have some slides on some of the major ones. So we had a bunch of editorial issues. There were some IDL problems, some other nits. We modified the big picture slightly, and we separated some references into normative and informative. There were a lot of WebRTC 1.0 compat issues. Those included adding identity support in, which we did in the latest editor's draft. We synced the GetStats statistics capability with some of Harold's more recent proposals. We had an issue with data channel compatibility where we were using a promise and WebRTC was not, and so we went back to the WebRTC model. And then there were some issues with voice activity detection and RTP, RTC non-mux. Next. So we had, actually, so We had some issues relating to scalable video coding that we'll talk about today, and those include things about how you advertise your capabilities and parameters. We put in some examples and some layering diagrams, and then there were some questions about the meaning of max temporal and max spatial layers. In terms of ICE, we'll have some substantial discussion today, but there were a lot of ICE issues fixed, and there's still a lot of ICE issues remaining. So ICE is a pretty hot topic, and we'll talk about a bunch of those. And then last is there were a lot of questions about RTC, RTP parameters, including CNAME and synchronization, issues about what it has to be filled in when you pass it to send or receive, what you get back, how you retrieve the parameters that were actually executed, when the parameters are in various states, do they change, do you get events? Robin will talk about a bunch of those. And then some specifics about what the capabilities are for individual codecs and the parameters. We're still, I think, figuring that out, but we put in a few things. And then also a few things about what header extensions are actually required and should be on the list of things. So that's more or less a summary of everything that we've been dealing with. So one of the first things we did is we updated the big picture. There were two things that were changed there. One was we put in the ICE transport controller, and the second one was we removed capabilities from the DTLS transport, since that only has params. So there was a question about whether it was accurate. So we modified that. I don't think there are any other changes in the big picture, and hopefully now it represents the overall picture. We then looked at normative versus informative references, and we denoted the ones as informative that either were informative in the WebRTC 1.0 API, were not referenced normatively in any IETF RTC web working group document, or probably anything referenced normally from those, and were no better than optional in any IETF RTC web document. So in the process of going through all the references, we noted some strange things. One of them was that RFC 3389, which is comfort noise, was not mentioned in any RTC web document, and there's a discussion now going on about whether that should be mandated in RTP usage. Another one was, I still am not quite comfortable with, is that there's no FEC recommendation in the latest RTP usage draft, and there's a discussion going on about that. Yet another one is that application ID is not currently mentioned in any RTC web document, and there's a discussion of removal from bundle on the mMusic working group list. So those things conceivably might, the comfort noise app ID and the effect might change depending on the discussion. Another one was that RFC 5450 transmission time offset was not mentioned in RTP usage, but there's people who feel it kind of needs to be there for congestion control reasons. So again, that's probably something to bring up in RTP usage. And another thing we found is we were missing a reference to 6051, which is rapid synchronization, which is mandated in RTP usage, but wasn't in the document, so we put that in. So anyway, this will be a topic which we'll be continuing to discuss, and hopefully those issues will be resolved and will get fixed in ORTC as well. A little bit about IDP support. We decided to put that into the latest editor's draft based on a suggestion by Martin. And so the way it is now is there's this separate RTC identity object which is constructed from a DTLS transport. And there are two methods. One is get identity assertion, which combines the functionality of set identity provider and get an identity assertion from WebRTC 1.0. That is, when you call this, you get both of those things kind of in one. And then set identity assertion, what it does is it validates the remote peer assertion. Now, if and both of these are promises, get identity assertion and set identity assertion. So if the promise is rejected, you get back an RTC identity error object. Anyway, that's the way it currently works. So one of the questions that comes up, because these are minted from DTLS transport, is if RTP and RTCP are not multiplexed, and then you're going to build distinct RTC DTLS transports for each one, and then you could build an RTC identity object for RTP and another one for RTCP. Great. Well, what happens if you call RTC identity.getIdentityAssertion with different values for provider, protocol, and username? So you could do this on your browser. And what happens if, when you call set identity assertion, you get a different assertion for RDP and RTCP? So next slide. So at least in the current version, we put in 2 notes, basically saying, if you're in your application, please do not call get identity assertion with different values of provider, protocol, and username for RTP and RTCP, because in WebRTC, it will treat this as an error. And so one question is, can we actually have the browser do this automatically so that a developer can't fall into this hole? And currently, things don't work quite right because you don't know these RTC identity objects for RTP and RTCP are linked. So one question has been, should there be some kind of component in the DTLS transport so that it knows that they're the same and potentially they can share info? So that's still to work on. The other thing was on the validation side, people were asking, well, is this, say the other person gives you 2 different assertions for RTP and RTCP, is this always an error? It's certainly in WebRTC 1, it always is an error. But there are some proposals in AVT core that could potentially make this not an error. And that's the whole discussion about cloud SRTP. So at least as of the moment, what we have here is that if you want to be compatible with 1.0, you must consider it an error. And again, if these 2 things were more closely linked, maybe that could happen automatically, except if the developer overrided it. So anyway, right now is we have some notes and a couple of little homework items to figure out if we can do this a little bit more cleanly. Because I don't expect most developers to understand these kind of corner cases. We had another question about voice activity detection, which is what is the equivalent of RTC offer options.voice activity detection? Is there equivalent in ORTC? At least as of the moment, our answer is that this has to be done individually by the developer. The developer has to essentially set the comfort noise codec in the RTC RTP parameters object. Say I want to use comfort noise, or configure a codec with built-in comfort noise support such as Opus. That isn't really the answer some people would expect. And the question is, just because you configure the codec, do you mean that voice activity detection is supposed to be used? So another to-do is, should we add a knob to the encoding parameters to indicate that voice activity detection is actually desired? It's not in there currently, but that's the open question. Okay, next one was CNAME, and I believe Emil asked the question, first of all, is what was the scope of CNAME? And basically what we added here is we added a CNAME attribute to the RTC RTCP parameters object, so that the developer, I guess, well, you're saying, Robin, that it must be filled in when you call send.
Yeah, this is the change that this isn't how it currently works, but the change that we're proposing is that CNAME must be filled in by the developer, and depending on the discussion later on get parameters, you might not be able to learn the value from the remote party.
Yeah, so basically, right, it's CNAME is supposed to be set to a random value, right? And will the developer automatically know to do the right thing here, or will they just put in your email name or phone number and basically destroy all the privacy stuff that we vowed to do? I guess that's a question here.
And which is also the default by 3515, the email thing.
Well, yeah, it's right. The question is, if it's set by the system, you might expect that it would do the thing that we said to do in RTP usage. Whereas if it's just something the developer sets, they'll probably go off and do something dumb, right? So there's a question there. Okay, so simulcast and SVC examples. We added some layer diagrams and some more examples for temporal scalability, spatial simulcast, and spatial scalability. So those are in there. I'm not sure people will be particularly edified by the examples, but hopefully they'll make it more clear what those things are supposed to do. We had another question about layering capabilities. So RTP codec capability had max temporal layers, max spatial layers, and max quality layers. And this was there to indicate what the codec capability for with respect to SVC. So one question we had is there a capability for the maximum number of simulcast layers? The answer today is no. And so what it means is you can set up simulcast layers. If there's too many of them, presumably you could get back some kind of error telling you there's too many, but there is actually no explicit maximum capability right now. Another question was, will implementation support quality scalability? We hadn't heard anybody that wanted it, so the proposal was to remove max quality layers. And another question we got is, what's the difference between a max spatial layers of 0 and 1? Presumably, if you have a value of 1, that means you don't support SVC of that type. So I think the answer we came to was, it's not in there right now, was maybe the default value of 1 should be there instead of 0, and 0 would then be an illegal value. So you wouldn't normally set it to 0, but it would be set to 1. So a remaining question related to codec capabilities and parameters. So we didn't have really any values for codec capabilities and parameters for VP8, H.264, and Opus. So we added a few things for VP8 based on what was in the VP8 RTP payload document, MaxFR and MaxFS. For H.264, it's interesting because H.264 6184 has a ton of potential parameters and capabilities, and one of the questions was, do we need all that stuff? We were a little scared by adding all of it. So we started with two basic things, which was the max receive level and the packetization mode. And then people asked the question, well, should packetization mode be an array like all the modes you support? And we're hoping that as this discussion of the video document proceeds, that we'll choose a one mode that everyone has to do. And then this thing could go away because we know everyone did mode 1. But at least right now it's just set as an unsigned short, and you choose one that you do. And hopefully eventually this just gets defaulted so we don't even need it anymore, but we'll see. And for Opus, there's still an ongoing discussion because there's also a lot of values you could have in there. It's not clear how many of them are really needed because most of them are kind of a hint anyway. So I think we need more discussion there. But the basic idea was we had these things or capabilities, and then we asked, well, what are the parameters? And it seemed like for the things we had there, you could just take the receiver capabilities and stick them into the sender parameters and you'd be okay. Like the receiver would say, here's my MaxFR and here's my MaxFS. And then on the sender, in terms of parameters, you configure it and say, here is the maximum frame rate you can send and the maximum macro block rate you can send. So at least with the parameters we have so far, this seems to work. But I guess we'll have to develop it further and still see if that still makes sense going forward as we get more complicated. We might need something a little bit more sophisticated. Robin?
Okay, so I guess I'd just like to open the floor to any questions about any of the stuff that we just kind of zipped through, or and is everybody happy with the way it's going so far before we go into a whole bunch of detailed discussions about outstanding issues. So
you should also mention that there was a bit of confusion on the timeline for the CG meeting, and I'll take full responsibility for that.
yeah, the Eastern time versus Pacific time got a little messed up, and
so we had a pre-meeting to the meeting, so a lot of these issues were covered off with Justin Uberti from Google ahead of the CG meeting. So this is the reason he's not present today, and also why we've zipped through a lot of these slides, because we've covered off on them between the stakeholders. So if anybody has any more comment, I digress.
Okay, then let's continue, and maybe we can always come back if we discover something along the way. So our coming attractions really haven't changed from the last meeting. We still haven't written up the latching rules yet, primarily because we wanted to resolve some of these other outstanding issues that are coming up in the coming slides before we define this behavior. But I think we'll be able to tackle that one next. The DTMF stats and IDP and data channel are always going to be coming attractions, because if WebRTC 1.0 changes, we're going to see what does and does not apply for ORTC and presumably update accordingly. So nothing to report there unless there are changes in 1.0. So the issues for discussion for today are ice restart, ice gather, the states of ice, the RTP parameter handling, defaulting, that kind of stuff, the encoding parameter scale value, and calling send after send and receive after receive for the RTP sender and RTP receiver. And we've got detailed slides on each, so I'm not going to discuss that here. So next slide. So ICE restart in 5245-9111. I don't know how many ones. Anyway, it specifically states that when you do an ICE restart, you have to change the UFrag and the password related to ICE. That's not optional, and that's the mechanism in how you signal that there actually is an ICE restart going on. ORTC, we've adopted the same policy regarding changing the UFrag and password, but it does have some implications that we need to discuss. So next slide. One thing that's important to note is that the 5245 biz draft that's come out does not even have mention of what restart means, because they're looking at having that have a new home within SIP, because it doesn't necessarily apply to other mechanisms.
There was, Robin, if I may interrupt you, there was actually a discussion on music just recently about that, and those will be added to 5245.
Okay.
Well, no, I was talking about the password and UFrag.
Oh, password and UFrag one, right?
Yeah, but not all of the implications apply, but that's the one that matters for us. So because it must change in a restart scenario, therefore we have to support it as well. So what does it mean? Well, obviously the UFrag and password on ICE must change. All the remote candidates are flushed. All the local candidates are flushed as well and gathered again. It does affect dependency transports like RTCP. You don't flush one without the other. And we may also want to perform the same functions on all the other related transports. So if you're restarting, presumably if you're restarting audio transport, you may want to restart video at the same time and not do them independently.
Yeah, and the RTP and RTCP would restart together, right? They wouldn't.
They must. They must. So one of the implications here is that we may want to move a bunch of this stuff to the transport controller so that you don't do it on an individual transport. You do it on the transport controller, where you just restart the whole kit and caboodle all at once. All of the related transports get restarted. And so if that is the way we want to go, as opposed to doing on an individual transport, then we need to add a method in the transport controller, and presumably we might not need it in the actual transport itself, and just live with the fact that we're going to do it on the transport controller for now, and only if we absolutely need to add it on an individual ICE transport. That resolves the RTP versus RTCP issue, and that resolves how do you coordinate all these restarts at once. One question that is still a little bit outstanding is that, do we change the RTCP listener object, or do we simply change its UFrag and password? And the presumable answer right now is no, we don't change the object. We simply just change the UFrag and password, and that's because presumably the connected state in ICE continues on while the restart is happening. Therefore, you don't necessarily want, even though you're regathering and figuring out all your candidates in your game and you're retesting, you don't necessarily want to actually change all of your ports and stuff that you're listening and working with. So,
a couple of questions, Robin. When you call restart on ICE Transport Controller, you said the gather state would change on all of your transports as well?
yes.
Is the gather function now going into ICE Transport Controller, or you can still call gather like independently on all the objects?
Well, that's coming up in a coming slide, which is one of the questions that is outstanding as well because of this implication.
Another question is, are you saying that even if you call restart, do you have to what is the implication for the DTLS transport object that's attached?
Okay, so there was a question in the RFC regarding changing targets, and does that actually mean you're changing device targets, or does that just mean that you're retargeting, let's say, you're retargeting the turn server as opposed to the local device? And it seems to only imply that it targets, turn versus the local device or something like that, not actually changing the device. So it has zero implications on the DTLS transport. So you're not changing the DTLS transport.
But it has to renegotiate, right?
No.
Really? Okay.
No, not really.
No, it doesn't.
But you could have a different camera.
ICE transport remains connected.
Sorry?
The ICE transport remains connected during a restart.
Right, that's true, but...
But you can end up choosing a completely different candidate.
Yes.
And
Yes.
SSRDP is pretty strict about being bound to a specific port. So I don't think you can just preserve the context after a restart.
For SRTP.
For DTLS SSRDP, yes.
Right.
Well, the DTLS itself doesn't need to be negotiated. I'm not sure about the SRTP component to that, though.
Technically, it doesn't need to be. I mean, if we're just implementing client and server, I'm sure we can make it work with the existing key. But the thing is that other implementations of DTLS SRDP might be expecting a renegotiation.
I think that issue should be brought up into the IETF discussions as opposed to here, and depending upon what they choose, we will have to appropriately reflect that behavior.
Is there anything currently on the IETF that has a similar behavior?
Not that I'm aware of. My preference is don't change the keys. There's no, in my opinion, there's no reason to just because you're retargeting, there's no reason to actually have to retarget your DTLS and SRTP. That would be my preference, but I still think that that needs to be firmly resolved as an issue within the IETF.
Yeah, I think like we should probably look at the RFCs more, but they are, I think, a little bit vague on some of these issues. On exactly what happens.
Yeah, the decision there needs to impact the API if it needs to impact at all. To me, that's a little bit lower level, but certainly we need to discuss whether the DTLS state goes to a renegotiation or not. And there's two parts of that: is the generalized setup, which in my opinion doesn't need to change, and then there's the SRTP keying material, and that may or may not have to change depending upon the decision in the IETF. And I guess this issue does need to be brought up. Does that answer your question, Emil?
Well, I don't really understand if there's any discussion planned on that in the IETF, because from my understanding is that the IETF point of view on that would be that you have to renegotiate if you change your transport. And if we don't want to renegotiate, then that's the issue that needs to be brought up as an optimization. But I think that there might be issues with that. I was trying to figure out if there were some intermediaries, for example, involved in one case and not in the other that were terminating encryption. Some corner cases that might break if we decide to just preserve the keying context.
There is no discussion because this is the first time I've realized that this issue exists from my perspective, so I certainly haven't brought it up. I'm proposing that we do bring this as a discussion to the IETF, though. So I'm kind of punting it for that reason.
Yeah, I mean, it would probably be a question you could ask on ABD Core or something.
Okay.
Yeah, I think it needs to be asked. I think that's an important thing, and I'm hoping, I would love to see us not renegotiate the keying material to avoid some extra round trips that we don't need.
From an ORTC perspective, though, the only thing that this changes is basically whether the developer is going to get a state change event during the ICE negotiation.
Right.
I don't need to add any specific code for that or anything.
Yeah, correct. Does it cause a DTLS state change or not? That's the question.
Yeah.
Yeah. So we're not saying you have to stop the object or anything, right? Just get a state. Okay.
Yeah. Presumably, it would just be a state change if it's necessary. And to me, so the answer right now is yes, it will. And if there is some kind of optimization where it doesn't, then it won't. That will be the answer.
Okay. So yes, this object will stay connected. It just might get a state change.
Okay.
Okay. That's not too bad.
And also, we don't need to exchange the keys again. Same keys exchange,
Well, that
really going to stay. We don't need to send the key again. Because if we send the key, there'll be a risk to be compromised. Again, if we send it again, it's kind of
renegotiation.
Even it's the same key.
Mm-hmm.
I think the right assumption is the device has that key already. It's using different port, different really has potentially.
If it's the same device.
Yes, right. Yep. Okay, right.
Yeah, the ICE restart does not change devices. So that's non-case.
Well, but
How do we know that it won't change devices?
If you need to change devices, then you need to set up new objects. It's not a restart in this sense. Okay.
yeah, I mean, you have an ICE reinvite, right? And you don't. The ICE reinvite can specify different IP addresses and stuff like that, right?
Yeah, and it can potentially be a different intermediary.
Yeah, you don't know what it is. It doesn't
Yeah.
know a device changed, right? You just changed the.
It can be a completely new thing.
Right. So. Yeah, I guess I don't understand how you know.
Yeah, well, you don't. But in the case where you might be talking to a different device, you will have to set up, in my opinion, new objects. I don't see a way around that because you cannot maintain the DTLS object between them.
Then how do you know? How does the JavaScript application know whether to send new objects or whether to do a nice restart? It doesn't
Well,
really know.
For
Right.
if you're just using the ORTC API, that's your choice, right?
No, but I mean, the ORTC API might be setting an unreasonable expectation to the application because
Right.
it wouldn't really know which kind of restart to do. Do I do the API restart or do I reinitialize everything? We're kind of telling the application to do that, and I'm not sure that the application has a reasonable way of.
Well, let's ask a question. So in SIP, for example, if you were doing this, you send a reinvite.
Mhm.
It's got your identity and all your other stuff in it, right?
Mhm.
How would you have any idea when your answer came back, like what you were talking to? You know what I'm saying?
No.
So you're sending your candidates. The other guy
Yeah.
sends his candidates. For all intents and purposes, you could be talking to another
Endpoint.
endpoint or not, right?
Yes. Yeah.
SIP doesn't really particularly care,
Yeah.
right? So
It always treats it as a completely new thing.
right, always treats it as a completely new thing.
So in this case, if it's a new device, you're going to fit.
Yeah,
No, in which case?
In case we don't exchange the key again.
Yeah. In this case, yeah,
it
it's
will
totally
fit.
fine. Yeah.
It's good, right? In the SIP case, you would start a new DTLS
Yeah.
negotiation and it would never fail,
Yes.
right? Here, you basically could do something dumb and kind of assume it's gonna
That is the same
that
entity.
it's the same
but
entity,
it's
and
actually
then
a
you
new
could
one.
fail.
Yes.
Yeah, but that's again, ORTC gives you the tools to use either. So if you know that the case is you're not talking to a new device, there's no reason to do that.
Yeah, but I guess what we're saying here is when you send this reinvite, you have no idea who it is. So
Yeah, you guys are talking SIP, not ORTC. ORTC is different in that way, right? You know, in ORTC, you're under control of the conditions you're under. So if you know that it might change, well, then you're going to have to do something different than the case where you know it's not going to change.
So I think my issue with that is that the only thing we need to change for this to work is to make sure we also do a DTLS SRDP renegotiation.
Right.
In that case, it will just work always, even for SIP. Because in the other case, basically we're saying, you know what, we have an ICE restart mechanism here, but it doesn't work for you, so go and do your new objects, and now our ICE restart mechanism is for other people.
Mm.
Yeah, I mean, remember in SIP, right? The reinvite, you don't want to have to. While the reinvite is in progress, you're still exchanging media.
Mm-hmm. Yeah.
You don't want to like disrupt that, force people to like start tearing down objects or whatever, right? That would be bad.
Yeah. Yeah, you have to be able to roll back if it fails.
Right. Well, that you have to do too. But so anyway, I think we maybe need a little bit more thought on this.
Yeah, I think you do, because the whole rollback scenario is a whole complication as well, right? How do you roll back?
Yeah.
Right.
So it's not so straightforward.
No, it isn't. But just as a question, so are we saying, at least as of right now, we're going to add the restart method to the ice transfer controller and also the gather method?
I haven't even talked about gather yet.
Okay.
So we can go. Why don't we go there now, and let's leave this. I think this ice restart needs a little bit more discussion on the list, especially regarding this whole DTLS exchange thing, because I'm hearing conflicting information from different people's opinions about it, and we all need to get on the same page as to exactly what it means. Does it mean retargeting a new device or not? Because if it does mean retargeting a new device, that is very different implications. And if rollback must be supported, that also has implications.
Yep.
Mm-hmm.
So we need to get on the same page for that before we can even figure out what the API needs to do or doesn't do. Okay, so gather policy. So the important thing about gather policy here is that you can go from a more restrictive to a less restrictive, and a less restrictive to a more restrictive. For example, you can go from no localhost candidates to having all candidates, or vice versa. So why is that important? Go to the next slide. Next slide. So if you're going from a more restrictive policy to a less restrictive policy, in theory, you could just omit the new candidates and go about your way as if it's just new candidates that have been discovered. There's nothing special to do. However, if you go to the next slide, if you're going into a more restrictive policy, then some of the candidates that you have are now forbidden. So essentially, you have to flush all your local candidates and remit them. So the problem becomes, how does the JavaScript developer know when to flush or not to flush if you were to do this behavior implicitly from one scenario to the next? So if you go to the next slide, the solution is to make the gather an implicit restart so you don't have differences between the two different scenarios. You're always restarting. And if you want to change your gather policy, you must restart. So if you must restart, that has implications to the restart method on the transport controller. And then the question becomes, well, do we want to have the gather on an individual transport? And does it make sense to have some transport have local hosts and some transports not, if they're all related within the same controller? So the answer so far has been pushing towards, let's move the gather policy into the controller, just like the restart method is in the controller, and have it done there. So you're doing it for all the related transports all at once, and you're restarting them at the same time.
Yeah, so there was just, I think, a discussion on W3C 1.0 about a similar issue. And I think the resolution there, at least for the case of going to the more restrictive, was that it wouldn't take effect until the next restart. So are you saying that gather implicitly causes a restart, or just it sits there and when you do a restart it takes effect?
Well, either. It could be either. I think we have to define what it actually means, whether it's implicit restart, or you have to manually call a restart before it takes effect. I'm okay with either scenario. But the important thing is that it must have a restart.
Yeah. Well, you're generally making things more like W3C 1.0 will probably make the transition easier, so that's just my opinion.
Yeah, or put a gather policy as a part of a restart. As a parameter.
Yeah. That was one.
Yeah.
Because otherwise you end up in a situation where, wait, what is my gather policy currently? It's this, but did I set it that way, or was it like that before? So
yeah.
Just in case that wasn't clear, that was a suggestion from Shijun from for.
I couldn't make out the suggestion. I'm sorry. Can someone repeat it?
Yeah, the suggestion was to make the policy a parameter of restart.
Yeah, that's a possibility as well. I think all of them kind of have the same implications in some way. You do have the important thing is that you need to do a restart, whether one method, two methods, combined method. I don't really care, but it's important that you do the restart. That's the important takeaway. Does anybody think that they actually need the restart and the gather policy to be on the transport, on an individual transport, as opposed to just saying on the whole controller, do all at once? Does anybody feel strongly that they need individual transport control as opposed to on the controller, where you're handling multiple transports simultaneously?
Yeah, personally, I think it's confusing to have it, be able to call gather and restart individually on individual transports. That seems weird.
Well, so individual transports that to SIP would map not only to RTP and RTP, but also to different media lines, right?
Right. If you're not muxing, yeah.
Yeah. So bundling.
If you're not bundling. So.
Yeah. So in SIP, you can restart it individual M lines. Now, I'm not insisting that we should be compatible with that, but if we don't allow that, then we wouldn't be compatible with this case, and we should know about it at least. Did that make sense?
No. Are you saying it's not legal or illegal?
You can actually start individual M lines in SIP. So, and if we don't allow that here for individual transports, we won't be able to support that case. And I'm not saying that we should. I'm just saying that we should be aware of that we're losing this thing.
Yeah, the controller kind of makes it like a bundle. Don't forget that. So you can always have individual controllers.
Yeah, I guess yes.
Yeah, in Ringbytes, you just send new ICE credentials as media line, as media parameters.
Yeah, so I guess in WebRTC 1.0 you can restart individual M lines.
Yeah.
But you have individual controllers then, or are they bundled?
Sorry, if you're unbundling, you have individual controllers?
No, what I'm saying is you could do individual, you could have each transport within a controller, and then that could be a mechanism to restart it, but then you don't get the advantage of having the combined controller for bandwidth estimation as well as for freezing. So the question is there ever a case where you have freezing behavior but can restart individually? And if the answer is yes, then we need to have the restart on the individual transport.
Yeah, I think that in an SDP offer in WebRTC 1.0, if you start with one offer, then the freezing behavior is common to every M line,
right? And
then you can still restart individual M lines. My bet would be that none of the WebRTC implementations currently support this. I wouldn't expect them to, but the protocol allows it.
Okay. Well, okay, so the protocol allows it. I guess then the other question is, you're right, because your question is, just because they allow it doesn't mean that we necessarily have to allow it unless we figure that we must. So I think we're going to have to punt this one to the list, and my initial gut reaction is say, no, we don't need it on the individual transport, but we should certainly make this point clear on the list and hash it out to make sure that we don't feel that there's a need.
Yeah, I will say, at least from my perspective, when I read WebRTC 1.0, it doesn't feel like they're kind of enabling that kind of behavior or restart of individual M lines, but that could be yet another topic that it's not clear about.
And that sounds like the kind of thing that Ericsson would like to support, but
yeah.
And similar to that, right now, other policies available for each transport object. And if you move this together as a restart group into the media controller,
right, that's a state move.
They're gonna reset everything, and it's good, in a way, but might be some confusion as well.
Yeah. So, but I guess at least, Robin, I think the ICE states can be different for each ICE transport, right? Because one might be connected and the other might be disconnected. So at least the state is all.
I couldn't hear the previous comment. So, but yes, you're right. The states are different for each transport.
Yeah, Shijun was asking about, there's the I state, there's also the gather state. Shijun was asking if the gather state moves to the transport controller or not, if you have a gather method move there. Because then if you gather moves, gather policy moves there too, right?
The policy certainly in my opinion, belongs there, but whether the individual transports have their own gather state, yes, because they might be tied to different listeners.
Right, okay.
So that's the reason why.
The policy can move, but the state might be still individual.
Yeah.
Right. The policy applies to all, but the state is individual. Okay. So let's punt on any other remaining discussion regarding that and figure out the SIP issue regarding each individual M line regarding for the restart and seeing if we absolutely need to support that or not. So on this ICE state diagram, the question became, do you ever go back to new? Because when you actually do a restart, it remains connected. So technically, it's not going back to new. So it seems like a mistake that the restart goes back to new. And we pointed out that the WebRTC 1.0 actually says it goes back to new. And but that's not consistent in the 1.0. So there seems to be an issue on the 1.0 regarding the new state. So we're going to let the WebRTC 1.0 guys fix that. And it seems to be that it's never going to go back to new.
Yeah.
So we're going to remove the new state in hopes that they fix it, and if they don't, well, then we got to revisit this issue again.
I have a question. The diagram doesn't seem to be showing us going back to checking either.
Yeah, we know. There are other mistakes. It's not the only one.
But is that a problem with the diagram, or?
Yes, it's a problem with the diagram.
So from connected on a restart, we will go back to checking.
Yes. No. On a restart, it remains. If it was connected, it remains connected.
Well, then I might be off. But isn't the point of checking the checking state a way of telling the web developer, beware, you don't have connectivity right now, so you might want to tell your user or something like that?
But you do have connectivity on the restart. If you were connected, you remain connected.
But you were still checking.
Connected means that you're still checking, though. It's not completed.
Yeah, it says in 50-45 that when you restart, you're still sending media,
Yes.
but you are checking at the same time.
Yeah. So that appropriate connected definition of connected is that you're still checking.
Yeah. You know, if
Is that? Oh.
So what happens when you're you have a connection, you're talking to someone, you're incompleted, right? And then you do restart.
Then it goes back to connected.
Then it goes back to connected.
Yes.
Yes. Checks, proceed, and then you go back to completed once they're done.
Yes.
Okay.
Okay.
Yeah, there's nothing much in there now to describe this, so I think that probably was.
This diagram is mistaken. It doesn't show going from completed back to connected. It doesn't show go back to checking or disconnected. There's a bunch of state issues here, so we've got to revisit this one. But yes, on a restart, it would go from completed to connected during the restart, for sure.
Yeah.
Okay?
Yeah, I think there's issues in this. There's issues in ORTC. I think there's also issues in WebRTC 1.0. And
there are issues in both, and I think that's why we got ourselves all confused, because we compounded the issue instead of making it better.
confused in WebRTC 1.0 and ORTC, though.
Okay, so let's go to the next slide. Another issue that we have is that at least for ORTC, only the controlling side can go into the completed state. And there was an issue brought up by Inaki saying, why do we even need this completed state? From a JavaScript developer, do we care? And the answer might be, from a JavaScript developer's point of view, probably not, but from an engine point of view, it is important on the controlled side to know when it's completed so that you can drop unnecessary resources. But we have no way to signal right now to the remote side saying, hey, controlled side, the controlling side knows it's completed, because there's no signal implicitly. And we don't have SDP with some kind of magic value in there to say that it's completed. So there seems to be an issue on the controlled side to know that it's in the completed state.
I have two questions about that. The first one is just a clarifying question. When you do a new ICE negotiation, you do your connectivity checks during that time you're in checking. When exactly do you move to connected?
As soon as you discovered a candidate that works bidirectionally, you can go into connected.
As soon as you discover any candidate that works,
yeah.
And then, okay, and then while you're in connected, you can actually change candidates if you discover a better one.
Yeah.
Okay.
And connected means that you've gotten, like, this is the best candidate possible. There's no others that are better.
Yeah, completed. So I can't currently come up with a use case that says the application needs to know about completed here. But I still think I'm uncomfortable not knowing that in the application and I'm going to think about a use case.
Well, you might obtain it from signaling, right?
How would you obtain it from signaling? You're talking about the control side.
The control side, yeah.
Okay, I was addressing first Inaki's command that said, why do you need completed at all? I think that's necessary. And then as for the control side, yes, you can obtain it from signaling. But why would you want to add an additional round trip time when you actually have the information locally?
I don't think you do. You don't know that the controlling side isn't going to switch to a better candidate because you don't necessarily know.
Well, actually, that's only true. That's only true for aggressive nomination.
Mm-hmm. Right, for aggressive.
Which is the default.
Well, no. I mean, the default from what perspective? From 5245, it's not. It's
the
kind
default,
of
like by default is in aggressive mode.
Existing implementations use aggressive mode.
Yeah, and there was some discussion in 5245 bis that this is a problem and there needs to be a message on the ICE layer that says that we're now done. And I think it would be good to factor that into the API and make sure that.
Yeah, if that were fixed, then you would know, right?
Yeah.
Yeah. I think that's the appropriate answer is to try and. I'm trying to turn down my ringer. I think that's the appropriate answer is to hopefully resolve it in the ICE spec because it seems like an oversight that both sides can't know that it's completed so that they can automatically release their resources appropriately.
Yes, and the reason I'm saying that is that we shouldn't be throwing too much effort into understanding how to handle that issue. I mean, we should keep in mind that this is actually an issue with ICE, and it's probably going to get fixed there. So.
Yeah. Okay. Well, then we can go under that operate under that assumption for now. The question still remains as to what value it has for the JavaScript, but I think we've heard enough people say, well, I can't really figure out a use case, but my gut tells me that we kind of want it. So, and it's not really all that big a deal to have it because the engine has to know it anyway. So I'm okay with leaving it.
Sure.
Okay. Next slide. Okay.
Want me to talk about this one, Robin?
Yeah, you can.
Okay, so RTC RTP parameters are passed as an argument to RTC RTP sender.send and RTC RTP receiver.receive. Now, at least the way it's been currently, there's parameters that are optional here. So, for example, on sender.send, we're assuming that the developer might not know what SSRCs are being chosen by the browser to send. So these wouldn't be filled in when sender.send is called. And there's other things we've just talked about, like CNAME, where conceivably the CNAME would be set by the browser, but the developer wouldn't know it when they call send. But on the other hand, you may need to signal these things to the other side. So the sender would need to know what SSRCs am I using so I can tell the receiver so they know what to put down into their receiver.receive call. Okay. So a couple of questions have come up. Well, how do you retrieve the parameter entries that are set by the browser? Because you need to signal them. Well, how do you get them? You basically, when you called sender.send, you didn't have them. And now you need them to signal, and how do you get them? And the other question is, when would these things be available? So when sender.send returns, are they all filled in? So now you have them, and you can take them out and signal them, or are they not filled in? And if so, when do they get filled in? So those are, and in the case, same thing with the receiver, right? For example, say you didn't know what SSRCs, were coming. Do they get filled in later or something like that? So that's the general question. Next slide, maybe. So we thought of some ways to get the parameters, which is you could include a get parameter method for both the sender and receiver. But then the question is, are these really needed? What are you going to do with it? So an example is on the receiver. Why do you care what the parameters are? For the receiver, generally you have to fill in a lot more things. Like you have to fill in the SSRCs, or else you get RTP on handle events. So generally you will fill them in. And the question is, what would you use get parameters for? We already have RTP on handle events, so if something wasn't filled in that needed to be, you're going to get this event, and presumably you're going to be told, hey, there's this SSRC showing up, and you'll configure it in the receiver RTC RTP parameters. So it wasn't entirely clear why you would want to call get parameters for the receiver. And similarly for the senders, really the only reason that you would need to call this is if there's something that's not filled in that the browser chose that you need to know to signal, like the SSRCs. And so a question came up, well, instead of not filling this stuff in and then having to call get parameters to get it so you can signal, is there some better way, for example, that you could get the information, fill it in before you call send, and then you know what it is to begin with? So instead of not filling it in and then having to retrieve it, could you somehow get the stuff you need, and then just when you put it in, you'd have everything? Does that make sense, Emil?
Yeah, I think so.
Yeah. So next slide. So specifically, the question is for sender.send, are all the parameters pre-configured before you call it? So should we require everything to be filled in? And then another question is for the receiver, do these values actually change? So for example, as latching goes on, say you had a receiver and you only filled in the app ID, right? It latched and you now know the SSRC. Does that get filled in so that does that get filled in over time, and do you actually care about it or not? And would that call change the RTC RTP parameters that you would retrieve when you call get parameters? So for example, if it latched, would you get now stuff filled in this SSRC where it wasn't filled in before? And is there some kind of, and are there events that get thrown as these parameters change, or do you not care? So that's the question of when these things are available. Now some other questions have come up that are actually even a little bit trickier. So for some codecs like VP8, the decoder can decode whatever the encoder can send. And so for that reason, there's no real reason to configure layers in RTC RTP parameters. So for VP8, for example, the receiver might not either know or care that the encoder is set up to do temporal scalability. It doesn't really matter. The decoder can decode it no matter what. So it doesn't even have to put in any layers at all. And so the question is, but on the encoder, you probably need to tell it to send layers. And maybe, so that would be something you'd encode before you call send, but not necessarily on the receiver. And so another question is, if you call receiver.getParameters, what does this give you back? Does it give you back what you put into it? So in other words, you didn't configure any layers, you didn't really care. Or does it actually tell you what the sender is sending to you at that moment? Like the sender is sending you 3 layers and it actually gives you back what it's sending or not. The proposal here is that we're not going to dynamically update RTC, RTP parameters for things like this. So what you would get back in the BPA case is you just get back essentially the configuration you put in with maybe a few things filled in, but we're not going to dynamically update it for the number of layers that's showing up at this particular moment. And another question, yeah.
I was actually going to interrupt and say, actually, the current proposal is that we don't have get parameters at all, either on the sender or the receiver, that for the sender side, you have to pre-configure everything. And on the receiver side, because we don't see a use case and a value for the information, there just is no need or demand for having a get parameters at all, even though some stuff could become filled in over time. So continue, sorry.
Yeah, certainly if all you're going to get back in RTC parameters is what you put in with receive, there's no need for get parameters. It's not changing, right? You just would save, you just store what you're going to put into it, and it's always going to be the same anyway. So that would decrease the need for it, right? It's yeah. So yeah, when we go back. And then if everything is similarly, if everything is filled in when you call sender.send, then also, and it's not going to change, that would decrease the need to have a get parameter there. But then the question would be how you would get some of the information before you call it. So another question is, what if the browser can't do what the developer asks for? So you call sender.send and you say, hey, I want 10 layers of temporal scalability. Maybe the max temporal layers was 6, and or 3 or something. You called it with 10. What happens? Does the browser change it to say you should only do 3, or do you get an error? And the general principle here is if you don't want to require this get parameters, then the answer is you should get back an error. Because if the browser starts changing it, then you really need to know here's what I asked for, what did I get? So it's a little bit simpler if you get back an error there. And again, you'll always know that you either got what you asked for or you got an error. And so again, you don't need to get parameters because it's not going to change. So that makes it somewhat simpler. Does that make sense?
Yeah.
Okay.
Because if you didn't have an error, then you have another problem. If you're requiring on get parameters to see what got set, how do you know when to ask? Maybe you asked and it didn't change, but it was too early, and
yeah. So we were discussing ways that you could know, like we could have promises, but all of this complicates your life at the end of the day. And so if you just know you're going to get what you got or an error, one of the two, then life becomes simpler. Okay. So the answer is here that RTC, RTP parameters is not a hint. You either get what you asked for or you get an error. So back to you, Robin.
Okay, so slide 36. Okay, so this has to do with the encoding parameters and the scale value. And there's a bunch of different scales, but I'm just going to illustrate the resolution scale. So first of all, what do you set these to, and what do the values mean? So let's take a particular use case where the programmer wants to send a stream at 33% original size, and presumably that's actually 1/3, so maybe 33.3 repeating percent, with 2 spatial layers. So the base layer you would define as being 1/4 the size, the resolution, the first layer being 1/2 the size, and then the second layer, the most enhanced layer, you would do the full size, which is 0.3% repeating. Okay, so those would be the values that you put in. Next slide. 37. Yeah. So the issue becomes when you set this resolution scale, the values might not be correct because of 2 reasons. One is program error, It's an awfully confusing value to put in, and if you're not familiar with SVC, you're going to get it wrong. And typically how we handle programmer errors is through exception. But it could also be an error because of floating point rounding issues. If you have 1/3, that's 33.3% repeating, and you multiply it out by 1/4 or 1/8, you're going to end up with some wacky values, and through the layers, you might have a value that's pretty close, but not exactly right. And how forgiving must our API be? And do we throw an exception error just because it's rounded slightly differently? So the answer we'll discuss in a moment, which is 38. The resolution we actually discussed in the previous meeting at the 11 a.m. Eastern Time meeting, which is to change the scale not from being the decimal number, but to actually being the fractional base denominator value. So if it's 1/3 the size and 1/4 the resolution, the base, then the scale is 12. So 1/3 times 1/4 is 1/12, so therefore the value becomes 12. And the first layer is 1/3 of 1/2, which means 1/3 times 1/2 is 1/6, which is the resolution is 6. And then the final layer is 1/3 times 1/1, which is 1/3, which equals a 3 resolution scale. So by changing it to the denominator value, you're going to remove any repeated, like 33.3% repeating kind of scales, which means you're not going to have funny values like that. Therefore, you're going to eliminate the rounding issue. Sure, you could have a scale of 2.5 or something like this, but none of those values are going to have any weird rounding issues, which you get from having like repeating decimals or crazy stuff like that. So this is the proposal of what to change the scale to resolve that issue.
Yeah, so to be clear, it's still a double, right?
Oh yeah, yeah. It's still the base layer is still 1/12. The first layer is still 1/6, and the final enhancement layer is still 1/3. So it is a proportional, 1/1, 1/2, 1/4, 1/8, and so on progression. But it's just using the denominator to eliminate any kind of weird rounding issues that we might hit.
So another question is, the numbers can still not be in the proper proportion. Like instead of 12, 6, and 3, I can make it 11, 5, and 2 or something.
If you don't use the proper proportion, it's a programming error and therefore an exception.
It's an exception. Okay.
Yeah. So this allows you to not have exception because you still have to define it right, but you're not going to get exceptions because floating point errors or fractional, decimal conversions and stuff like that happen. Okay?
Yeah, so you can still shoot your foot off, but the gun won't go off just for no reason.
Yeah, it's not going to be hair trigger. You still got a loaded shotgun, but you don't have a hair trigger that's going to go off by just breathing on it. Okay? All right. So that's our proposed resolution. I hope no one has an objection, and I think we should still hash this one out for all the different scales and see if it makes sense. But that's the current proposed resolution. The next issue is calling send after send and receive after receive. So the idea being that it's completely legal to reconfigure whatever you want in the sender and just call send after send. And the same is true for the receiver. However, there is a bit of a caveat. Because of weird things with rollback and all sorts of issues that happen with SIP, you can't just change your payload type from being one, like take the H.264 codec and assign it to be the VP8 payload type and the VP8 payload type to be the H.264 payload type on the receive and call receive and just expect it to be all happy and hunky-dory. There are going to be things that are going to be illegal like that. So yes, it's legal to call send after send and receive after receive, but there are going to be restrictions that are going to be disallowed. So it's legal, but within a restrictive framework, and we're going to have to define all the specific rules as to what is legal and what is not legal. We haven't gone through that process because we were still discovering whether it was legal at all in the first place. So the answer is yes, it's legal. That's the proposal, but within restrictions.
So there will be restrictions there are restrictions, right, in the JustUp API.
Yes.
So I guess we'll copy those. Is that the idea?
We'll start with copying those and seeing if there's anything that we can relax or if anything that we need to tighten for whatever reason.
Just one clarifying question I didn't understand. You're saying that if I co-receive and then change the payload type and then co-receive again, this is problematic. Why?
Because you're in an intermediate state. Like if you were to swap out the VP8 for the H.264 and use each other's payload number, you can be in an intermediate state where you're receiving the packets from the old but swapped in the new, and it causes confusion. You want to eliminate that as a possibility. So you can add a codec, you can do stuff like that, but you can't swap the codec numbers around or something like that to something that's already been used, because it'll cause all sorts of confusion.
Time-wise, do you need to how do you synchronize the send, and then receive? I mean the second one, because if you call send with a new parameter and then the other side isn't ready yet, there's a timing issue.
Yep.
How do you resolve that?
It depends on what kind of, you have to take that on a case-by-case basis, because some of the issues don't happen. Because presumably, if you're just changing codecs and the receiver is already configured with the codec, but it's just not the current default, it'll just happily go along. And if you're if you're doing VP8 and you're changing the layering, VP8 has a rule where you're allowed to decode anything, so that's presumably A-OK. But there's other cases, like you're right, where you're calling one thing and there could be a race condition. Now the question becomes, do we need to make it illegal because it could actually go into some really, really funky states? Or is it just merely that the packets are going to get dropped on the floor, or possibly can have an unhandled RTP event under those scenarios? And I think we have to look at it on a case-by-case basis and discuss each individual thing that can change, and what is legal, what is illegal, what has an unhandled RTP event, and what does not, and so on.
Like one use case here would be a reinvite.
Would the reinvite be receive, or would it be a complete reinitialization? Or
well, I mean, I'm thinking it would be receive because I'm sending the reinvite. I want to continue to have the media is continuing to flow, right? So it has the interesting property where I can be changing things, but I don't want to stop the media that's already coming in. So I kind of have to keep most of the receive parameters I've got going, or else stuff will start, I won't be getting, packets will start to fall on the floor. I might add something, and then when the offer comes back, I might change my receive again, if you see what I'm saying.
The reinvite is exactly the scenario where we're talking about, because the reinvite scenario, you still have to handle the old packets that are coming in, because they might come in. You have to be able to accept new media because the other side might accept it, and the other side might reject it, in which case you need to roll back. So you have to be able to support receive where you can handle all those scenarios.
Does that make sense, Emil?
yeah, but the case, for example, where I'm getting VP8 is 99, and then I suddenly want to say, by the way, if you get 112, that's also VP8. This works, right? This works.
That should be legal, but I would say it's probably illegal if 108 or whatever number you picked was already chosen for H.264.
But imagine that it wasn't.
Yeah.
Well, then I don't see a problem.
So it would work, right?
Yeah, I mean, you started off getting it at 108. Now you could add another one for 112. That would be okay because you'd still be getting the receive stuff on 108.
Yes, yes.
And now you're saying I'm also willing to receive it on 112. Now the answer could come back saying I don't want to do 112, in which case fine, I'll get rid of it. Or it could say, or it could switch or not, and either way you'd be okay. Because if it said no, you could just get rid of the 112 and you'd be rolled back to your previous state. Or if it changed, you could get rid of the 108. So
And presumably you could probably work around the exception by not doing an immediate swap, but dropping one and then adding it back, and then therefore make it legal. But the point is that it's not going to allow you to do something that is flatly, can have problems. So.
Yeah, but so it's not going to allow you based on current state, not based on API inability to do that. Basically, if there's no conflict, it's going to stay silent, right?
Yeah, that's right. And so we have to look at it on a case-by-case basis and look at all the different things that can change and what is legal and what is illegal. And we're going to start with the JSEP and work from there.
Mm-hmm.
Sounds like fun.
Yeah, I'm really looking forward to this one. If anybody's sarcasm detector was not off, then, Anyway. Okay. So those are kind of the outstanding problems that we're working through right now. And just to recap, we've got a bunch of ICE stuff with the restart, the gather, the controller versus on the individual transports that we've got to punt to the list. We've got the whole controlling versus controlled, the completed state there, and whether, what do we do there. And we've got a whole bunch of, we're going to presumably drop Git parameters entirely until there's a real use case for it. And we've got to work through a bunch of issues regarding this whole send, and receive in terms of legality. But presumably we're almost there. And I don't think there's any reason why we can't start working on implementations right now. I think the API is pretty much stable enough to do that. There might be just a little bit of retweaking of moving like the restart from one place to another or stuff like that, or adding it in. But behind the scenes, the engine's all got to do the same thing. So we are looking towards working on implementations at this point. And it's also a good time if you see any fundamental problems or flaws, good time to speak up, because we're going to be working on implementations now.
Yeah, I mean, I think what we've just talked about is a fair number of changes, so it might be good to try to spin this around pretty quickly.
Yeah, so we're going to come up with a new, certainly an editor's draft at the moment, but hopefully come up with a, a more finalized version for implementation feedback.
We should talk about that with you.
Are we done? Because I have one question that is not critical.
Yeah, we are presumably done with 2 minutes left, so the floor is open for anything at this point.
So I haven't been always following very strictly. I just wanted to make sure: is it still possible to create a receiver, just set the payload type, and not require SSRCs and any such things? Is that still possible with the API?
I believe it is, Emil. So let's talk about that. So you set the payload type. Well, see, this is one of the questions I think that may have just been impacted by what they said. So you know the payload type, you don't know the SSRC, but you only have one stream, so why should you care? Right? Like particularly for audio.
That's one case, yes.
Right? So what we had thought of was basically you get your first SSRC, that kind of automatically latches into the payload type.
And everyone is anonymous.
Right. And I guess from what we're talking about here, because if we get rid of get parameters, then it's not like this SSRC would show up and there's some way of retrieving it. Mm-hmm. It just kind of works. Mm-hmm. The ones after that, I believe, would create an RTP unhandled event. Mm-hmm. And then you could go and plug it into your receiver and add an SSRC if you wanted to.
How do I add the SSRC?
Well, you would basically create an RTP parameter structure and put it in, and then call receive.
But why would I do that? I mean, it has an SSRC. Why would I add?
Well, if it already has one, you don't need it. I'm saying the second one.
Yeah, the
this
second
would
one.
be for like video or something.
Yeah, imagine a video stream with 10 SSRCs, all coming on 96 payload type.
Right. So you could just put in payload type 96. The first one that comes in will auto latch. Mm-hmm. Okay. Then other ones would throw an RTP unhandled event if you didn't, right?
And can I get the SSRC from there?
Well, you would get the SSRC from the RTP unhandled event.
Okay.
And then you could put this into an RTC RTP parameters object and add it.
And by the time, during the time while I do that, are packets going to be cached or?
They will potentially be buffered, but not very much.
But
so,
it would allow me the time to do this thing.
Hopefully. It's a little bit tricky because you're getting video frames, and that's could chew up a buffer pretty quickly.
Yeah.
But hopefully, I see your concern, which is you just dropped the iframe, right, and filled up your buffer, and now, fun times.
Yeah.
But I think
the idea is that the engine will do a reasonable job to try and preserve what it can, and so that we don't have loss during the setup time.
Yeah, I mean.
But the thing is that I have to use the unhandled event, and I have to manually create the receiver from that unhandled event.
That's one way, or you can pre-configure it.
But only the first one. Or you mean that after I get the first one, I can pre-configure another one for the same payload type?
Well, so the issue is here, you would get all the information you need in the answer, but presumably the reason you're doing this is you don't have the answer yet.
Yes, presumably.
If you all the SSRCs you're going to get, you could just push them down.
No, but I don't want to have SSRCs in offers and answers. That's my problem.
Yeah, if you don't want to have them at all, then the question is, then you get the RTP unhandled event, and right now you would have to. You're saying this thing is coming out on 96. I know I'm not doing FEC or some other weird stuff, so I kind of know this thing is actually a video stream, and then you would actually go and plumb it down when you get the unhandled event.
Or I'm actually thinking about the case where I do, so I have an offer answer taken place, everything is configured, I know about FEC, I know about everything, and suddenly a new SSRC appears out of nowhere.
Right.
And or 3 SSRCs appear out of nowhere. And that's the case I'm concerned, and because basically at that point the engine has everything it needs to know about these SSRCs. They're using the same FEC, the same everything. So it should be able to handle them, and I was wondering.
Presumably, Emil, that when the first one came in and it latched, you could presumably set up another one, and presumably you could even set up a bunch of them, and the first one kind of wins, and then the second one latches, and you could just have a queue of them ready to go. There's no.
Every time a new one latches, I prepare a new bullet. Basically.
Prepare 10 in advance. We haven't even defined those latching rules yet, and I would love to see it where you can have a queue of them ready to go. There's no reason why we can't.
Yeah, I guess the only complication is, like you said, you'd already set up your FEC so that you know anyone that's going to latch is a video thing, not some other thing, right?
Yeah.
So in that case, you would be able to latch multiple after that.
Okay.
But I guess we still have to write the latching rules to make it clear exactly what's supposed to happen.
And also from implementation perspective, before you set your receiver trap on the video type, the data gonna have to be buffered somewhere, and the buffer gonna be limited. So that will happen when you put on the video type at some time. In your pipeline, you have to ask for interface, because if the buffer, you run out of cache already. For some reason, you didn't even render that thing to anywhere.
So you're saying that you have to support FERS anyway?
That's right.
Yeah, but I'm just looking at you have to make sure we minimize the need for FERS.
So number one, you need to understand SSRC, what it's for, and then number two, when you set up the whole rendering pipeline, you might have to ask for refresh.
Sure. Yeah. Yeah, it's a separate thing.
Yep.
Yeah, so we still have to write the latching rules, and I do agree, Emil, it would be nice if you could get rid of as many unhandled stuff as you can. Because even a lot of video could show up even in 30 milliseconds, right?
Yeah.
I think I'm going to conclude the meeting here.
Okay. We kind of need to move on. So I think suggestion, Emil, is to take your ideas and stuff to the list of what you'd like to see. So that way, when we're writing up the latching rules, we can be sure to take that into account. Okay.
Thank you.
Thanks. All right. So on the slide here, we have links to the various implementations that we plan on having worked on. So if you want to work on them, by all means, send a note, and let's start contributing to these open source projects and getting underway with all the different implementations. Okay, next slide. How to join. There is an ORTC dev group. We've got a few people in there now, so please, by all means, join the group and let's start working on these implementations. And even if you're working on your own, it would be nice to see you in there so we can kind of collaborate on issues and discuss problems that we hit in the ORTC implementation. So by all means, join anyway. There's the link. And then a final thank you to Bernard and Michael and Justin and Peter and myself and Eric to helping with this process. And Emil, you've been very helpful along the way too, so thank you. And everybody else who's been really working to get this API finalized. And that's it. And for more information, the portal is ortc.org. That's the simplest place to go to as a launching point for everything else. That's it for this meeting.
Can I ask you a quick question, Robin?
Sure.
So, did we make any changes to the spec as a result of this meeting? I didn't follow quite closely enough.
Yeah, I think we made a bunch of changes.
Yeah.
Okay.
I have to do the notes to see exactly how many, but
I think we'll see an editor's draft that incorporates them.
yeah,
Yes.
that better.
We will be doing an update with all of the, because of the pre-meeting and this meeting, we will be doing an update regarding all the changes thus far. There is still a few outstanding issues, and I think that there's some things that merit further detailed discussion just to verify that we've got it right. For example, the restart only being on the controller and stuff like that. And a few behavioral issues that I think are still outstanding within the IETF issue. For example, the DTLS, does it require a renegotiation all the time or not, and all the rules there. So yes, we need to have a new draft, and there's still going to be some outstanding issues, but certainly we can start implementation.
So
Yeah,
are we going to call this the call for implementations draft, or the
Yes.
The next one might reach that. I wouldn't call the current one that state yet.
Yeah, there were a bunch of changes in the pre-meeting ahead of this meeting that are going to be incorporated into the draft as well. So
Yeah.
So any ETA on what the call for implementations draft would be? When?
I'm thinking days, not weeks, eh, guys?
I don't think that will be out before the ITF meeting is over. Let's put it that way.
Okay.
Right. Good point. Sorry.
So sometime this coming week.
Yeah, it's Bernard and I are going to work on it, I'm sure, in this coming week.
Well, we'll probably need to ask a bunch of questions in meetings that are going on. So not that. Let's just say not this week.
Yeah, fair enough.
Well, will there be an editor's draft this week then?
No, not this week.
Likely not. No.
So
Yeah.
the next draft will be probably next week, and it will be the call for implementations.
Yes.
That'll be
Okay.
the grand poobah for implementation. Yes.
Yes.
Okay.
Does that work?
Well, it would be better if you can do it today, guys. It's
No, yes, it would be better.
Yeah.
wow.
We'll teach you respec and you can have
Okay, I'm gonna go ahead and stop the broadcast, and we can continue on with a private conversation if you guys like. But I'm gonna stop the broadcast now. Thanks everybody for joining.